Up until this point, we've been working with React to create the front end of our application, what our user interacts with. But now we have to ask the question of the back end. Where is our data going to live? How are we going to get that data and bring it into our app, as well as make changes to it? So we have to figure out what's going to serve as the kind of bridge between our front end and back end. And the answer to this question is going to come in the form of a new tool, a new library called GraphQL. GraphQL stands for Graph Query Language, and it in many ways does serve as a new language for working with data, a very powerful one that we're going to cover extensively at this point. But as a means of better understanding GraphQL and what it brings to the table, let's look at an existing interface that you've likely used for working with data in the past, called a REST API. And just to refresh your memory, API just means interface for getting data or some other type of functionality. In the past, we almost entirely used REST APIs in order to fetch data and to work with it, to bring in data from our backend. So right now we're looking at a REST API, the Star Wars API, and it lets us get data from all the Star Wars films. REST APIs are normally based around routes, different endpoints that we can get data from. So if we want to get a certain type of data, we need to make a request, a GET request in this case, to a given route. So for the Star Wars API, that would be the films route. So in this input, we can just type in films. This is the entire endpoint that we need to make a request to. We can hit request to perform it. And once that request has been made successfully, we get back as our result this massive object, which includes all of the data that the API provides about the Star Wars films, the count, and then for each individual film, its title, director, producer, characters, etc. So normally, if we were going to include this data within a given app of ours, say a React app, we'd have to take this big object and then grab whatever fields off of it, whatever properties off of it that we needed, and then kind of throw away the rest or disregard the rest. This is in contrast to a GraphQL API. So this is a GraphQL implementation of the Star Wars API. It provides the same data, just using the GraphQL syntax. So right now we're looking at a GraphQL Explorer, a common one called Graphql. And as you can see here, it's an in-browser tool for writing and executing our GraphQL queries. So let's see how to perform the same request for all of the Star Wars films using GraphQL. To get data in GraphQL, we query for it. So we need to write a query. And we do so within a set of curly braces. Then we write the name of the query we want to execute. In this case, we want to get all films. So there is such a query called all films, but notice something interesting. When I type the first letter, I get this list of suggestions provided to me. And this is the GraphQL Explorer's IntelliSense working here. We'll see why this happens in just a sec, but we don't have to type in the entire query. We can just find the one that we want, in this case all films, and then it's immediately expanded and written out for us. But we're getting an error here. It's telling us that this field, this query, has a certain type that has a selection of subfields. So what does this mean? Well, as compared to a normal REST API where we just get spit back to us whatever the API provides, we, with GraphQL, have to determine what subfields we want, meaning what pieces of data we want back. So to write a set of subfields, we just add another set of curly braces. And within that, let's say we don't know what subfields we have, we can just type some letter, and then we get a couple of options suggested to us. So we'll select films. So yes, we want the film subfield, and it's telling us it's of type array, where each element is a film, and that has a selection of subfields. So again, we write another set of curly braces. And then what do we want for each film? Well, let's say we want the film's title as well as the director. Let's see if those fields are available. We can just type in T, and then we get title suggested to us. If we type in D, we get director suggested to us. And we're not getting any more errors, so it looks like we can execute this query. To do so, you can either hit the play button, or you can use the keyboard shortcut Control-Enter. So we'll just hit play, and we get back to us something interesting. The result comes back to us in an object. Note that this is in JSON format, as denoted by the double quotes around each object property. We get back JSON data, but it has virtually exactly the same shape as the query that we wrote out. So it's in a very predictable format as compared to the totally unpredictable result of our REST API. then within this data object, our data is always going to come back in this data object. We get all films, within it a films property, which is an array of objects which include our title and director values, just like we requested for each of the 7 films. So what have we already learned about GraphQL? It gives us data in a very predictable format. We know exactly what we're going to get. We get IntelliSense to suggest what fields we need to write. And this is because every GraphQL API follows a strict schema, which we can look at if we hit the Docs tab. If we look at the Documentation Explorer and then go into the query root type to list all of the available queries that we have, and we look at all films, we can see the name all films, we can see information about it, such as the data that it can accept, the arguments it can accept, and then after the colon, we can see what data it returns. So this is what Graphql was asking for. It was asking for some subfields that were of type films connection. So if we click on that, we can see a bunch of available fields. We selected films here. We could have also selected something like total count if we wanted to get the total count of the Star Wars films. We get that data now. But we selected films, and that is of type array, where each element is of type film. And in that, we provided the subfields title and director, which are listed here. So this schema is what gives us the IntelliSense, the suggestions for what to type, as well as gives us any errors when something's written incorrectly. So it's kind of a self-documenting API, so we don't have to go looking for where to find the documentation for the API that we're working with. If I didn't know ahead of time that we had to use the films endpoint in order to get the films data from the documentation, we wouldn't know what route to use. And finally, we solved this problem of overfetching, which is to say the problem of getting more data, a lot more data than we need. We don't need all of this data from our REST API to get, say, the title and director of each of the films. We can just say, give me all the films, then select this film subarray, then yes, for each film, we want the title and the director. So that was just a very quick overview of the benefits of working with GraphQL, why we'd want to work with it, why we're going to use it in building our apps. And right now we're going to dive into a lot more of its features, as well as how to work with it in conjunction with React. Now, instead of working with Star Wars data, which is going to be largely static and unchanging, let's use a GraphQL API where we can change the data in it. So I'd recommend you go to the following address, todos-graphql.herokuapp.com. This is a GraphQL API that I've created for the purposes of this course to work with some to-do data. And we're going to see how to create this entire API in just a bit. So as the name suggests, this is a means for working with to-dos. And note that we'll soon see how to not just get the data right here within the Explorer, but also within our React applications. But right now, we first want to understand GraphQL so we can see how to apply all these concepts to work with our data remotely from within our React apps. So since we're approaching a new API here, and we don't know anything about it, what's the first thing that we can do? Well, we could, of course, write our first query by opening up a set of curly braces and just typing something, or a more reliable way to figure out what we have access to, what we can do within our API, is to go to the Schema tab. Now, this is a different type of GraphQL Explorer, slightly different than the Graphical Explorer that we were working with, and it has some slightly different tools, but generally speaking, it's the same. To see what we can do, we want to click on the Schema tab. And right here, we have a list of all of the available queries and mutations that our API can perform for us. So we've covered queries at this point. Queries allows us to get data. That corresponds to a GET request when it comes to, say, working with a REST API. But what about mutations? So queries are for getting data. Mutations are for mutating or changing data. Mutations allow us to create new data, such as adding a to-do, as well as update data, such as toggling a to-do. We'll see exactly what that means in a second. Or there's also this update to-do mutation, as well as delete a given resource, delete a to-do in this case. So with mutations, we can create, update, and delete data. But let's better understand queries first. So we have one query here, get to-dos. Allows us to get all the to-dos, and as we mentioned, all of the data that's returned from a given query or mutation is after this colon. So when we execute it, we get back an array as denoted by these brackets, and to do what we see here is called an object type. There are two types of data in GraphQL, object types and scalar types. Object types are pretty straightforward. They are JSON objects. So if we click on this query, we can see what type to do consists of. To do is an object, which consists of an ID, text, and done property, or field. In GraphQL, we refer to properties as fields. And note that in addition to the object itself having a certain name, to do, each of the fields has a type associated with it. And they resemble JavaScript types. So text here is a string, ID is a string, and done is a Boolean. These are what's known as scalar types. These scalar types, as compared to object types, are built into the language. There are 5 built-in types in GraphQL: strings, any text, wrapped in a set of double quotes, integers, represented with the type int, those are just whole numbers, float, which are decimal numbers, booleans, which are the value true or false, and IDs, which are unique strings. So if we were to write out get to-dos, and we can write any query with a set of curly braces, we can also prepend it with the text query, the keyword query, although that isn't required. And we can also give our query a name. So we could maybe call this fetch to-dos, and then from it we want to get the field get to-dos. And we can just hit tab to expand it once it's suggested to us. Now we need to provide a set of subfields. We look at our schema again. We need to figure out from each to-do what we want to get back. And let's say we want to get all the fields. So we'll open up a set of curly braces and say we want ID, text, and done. And we can hit the play button. And it may take a second, but we get back our data object where get to-dos is an array of each of our to-do objects. And note that the data provided each on these fields, on each of these fields, is exactly as it was specified in our schema. Otherwise, it would result in an error. So in other words, GraphQL is a strictly typed language. Whenever we're working with data, we must declare our types up front. So fetching data or querying for data seems easy enough. We can just choose whatever fields that we want, hit play, and we get back the data that we requested. But what about changing data? What about mutating data? So let's work with our first mutation. So what's helpful when thinking about mutations or queries in general is just thinking about them like normal JavaScript functions. They take some input and give us some output. So for many mutations, for many cases where we want to change data in our database, we're going to need to provide it. To create a new to-do, we're going to need to provide all the necessary to-do data. So if we want to create a new to-do with this add to-do mutation, what do we have to provide? Well, if we click on it, we see that all that we have to provide is some text, which is of type string. Now what's this exclamation point mean after string? Exclamation points just mean that a given argument is required. You can see all the arguments down here at the bottom. So to create a to-do, and we see that a to-do is returned to us as compared to an array, to get a to-do and have it be created in our database, we need to provide some text. So let's start from scratch again. What's different about mutations is that instead of just adding a set of curly braces like this, we actually need to provide the mutation keyword. We always need to provide the keyword mutation whenever we want to perform it, as compared to queries where we can omit the query keyword. So when it comes to writing our mutation, what do we need to provide? Well, like with our query right here, we had to provide its name first. So the name was add to do. And then like a JavaScript function, we can add a set of curly braces. And immediately our Explorer knows what we need to provide. We need to provide a text argument. So to pass data to a query or a mutation, we first need to provide a named argument. So we can't just pass it in like this. It has to have a name. So we'll provide text, and then to pass the text argument data, we provide a colon. So after the colon, we can add whatever text that we want. So to add a new to-do, we might want to wash dishes, for example. And then we need to provide the subfields that we want back. We're returning a to-do. And if we can look at that, we can see that we get back text, ID, and done. So once again, let's get all of those fields. We can also provide a name for our mutation if we want. We can name it the same, add to do. Then we can hit play to execute it. And we get back our data object within it, add to do. Then we get all of our to do fields. Now notice to re-execute a query or a mutation, we don't have to rewrite it from scratch. We can just hit the history tab and then select which one we want to execute. So to see that it was in fact added to our list of to-dos, we can select our fetch to-dos query and then hit use. And then if we execute this again, we should see a new to-do at the end, and we do. So what about updating data? We saw how to run a mutation where we're creating some data. What about toggling a to-do? Well, this toggle to-do mutation, if we take a look at it, we can infer what it does based off of its name. It takes a to-do of a given ID, which is of type string and required, and what it will do is it will toggle it done. So for this last to-do that we added, by default, it's not done. Done is set to false. Our to-do hasn't been completed. So what if we have washed the dishes? We want done to be set to true. So therefore, we need to execute toggle to do. So let's write a new mutation. The mutation is toggle to do. It accepts an ID. We usually just have to add a set of parentheses, and then the argument's going to be given to us. We provide an ID, and let's take this last ID. We'll need to copy its value directly and paste it in here. Once again, make sure you use double quotes since we're working with JSON data. Double quotes for any string that we write. And we add some subfields. And once again, we get back a to-do. And in this case, we just maybe want the ID and done. Well, actually, we can provide all of the fields. And then when we execute this, we should see done set to true, and we do. So that's our toggle to do mutation. What if we want to update the text? Say, instead of having it be wash dishes, it should be wash the dishes. We can leave this to do up here. We can just click this plus button to add a new tab, so we don't have to keep erasing our work. Here we want to use the update to do mutation, and this takes an ID of a to do and text. And this is going to update the text to whatever new value we provide. Provide a mutation, the name update to do, or the ID. Let's take a look at the ID. We'll grab that, pass it to the ID argument, and then we also need to provide another argument, so we'll add a comma here, and then provide our new text to the text argument, and here we want to say wash the dishes. Make it a bit more grammatical, and then we can get back ID, done, and text. And let's run that. And we see done is still set to true, but now the text is wash the dishes. And finally, let's delete our new to-do entirely. Let's say we don't really want to see it anymore. We're done washing the dishes. Maybe this was something that we did yesterday, so let's get rid of it. So for our delete to-do mutation, it just takes an ID, doesn't need anything else, and we get back a to-do. So for this mutation, provide the name, provide the ID. We'll copy that once again. And we'll get back ID and text, let's say. And now to see that that's been performed correctly, we can just execute our fetch to-dos query once more. We should no longer have that last to do at the end, and we don't. And note that one additional trick that you can use is if your queries are looking a bit unformatted, if you need to format them a bit to make sure each level of subfields, field and subfield, is spaced properly, instead of having to format it yourself, especially if you have a very big query. Try to imagine our query or mutation was very large, where we had a lot of subfields that we were getting, a lot of nested subfields. If you didn't want to have to format it yourself by tabbing each part of it like this, you can just hit the prettify button, and the Explorer will do so just like that immediately. Now, believe it or not, we've covered a great deal of GraphQL up until this point, all the major parts that you need to know. But there's one additional feature of GraphQL that's going to become particularly important for us in using GraphQL in our React apps. If we take a look at any of our mutations that we've written and executed so far, you'll see that these values that we've provided to our arguments, say for this delete to do mutation, we've provided the ID to our ID argument, but again, using our mental model of functions, JavaScript functions, in relation to our mutations and queries when it comes to passing them data, here we just have a hard-coded value. This is not a dynamic value. Anytime we execute this mutation, it's going to be passed the same ID. So the question is, when we have in our React application different values for a given argument, different values for the to-do that we want to delete, the different IDs for the to-do that we want to delete, how do we provide those? How do we have dynamic values provided to our arguments in GraphQL? Well, let's think about dynamic values in general in programming. How do we store dynamic values? We do so with variables. So this is something that tends to trip people up when they're learning GraphQL. It seems to be a tricky feature, but it's not that difficult. To have dynamic values, we need to use variables, and in addition to all of the syntax that we've learned up until this point, we can declare variables in GraphQL and use them and assign values to them. So now, taking a look at our list of to-dos, let's say we also want to get rid of our first to-do with the ID of 0. But that might also change to the ID of 1. Instead of hard-coding either 0 or 1, we can go to our delete to-do mutation that we've already written out and convert it to use a variable. Now, since we have one argument here, we just need one variable, and the way that we declare variables is right after the keyword for the operation. So if we're passing variables to a mutation, we add a set of parentheses after mutation. If it's after a query, if it's for a query, we do it after the query keyword. We may need to add the query keyword to declare variables. And then it's also after the optional name that we give it. So we want to declare a variable that holds this ID value. Any variable in GraphQL is declared first with a $sign in front of it. So to keep this very simple, we're just going to make a variable $ID that's going to hold this ID value. But this isn't enough. We can't just write it like this. We also need to give it its corresponding type. So what type does ID have? We could look to our schema if we needed to recall ID is of type string. Now we also need to know whether it's required or not. So for delete to do, is ID required? Yes, it is. So we need to declare the type just like it is here in our schema. ID must be of type string. What we provide to the ID variable must be of type string, and it is required. So in many cases, we can look exactly to our schema to get the answer to this. Now, to pass this variable to our mutation or query, we can just replace the hard-coded value with the declared variable, just like that. Now, what about setting or assigning a value to this variable? Well, we can do so within the Explorer, within this Query Variables tab. So we can just open that up. There's a specific syntax for doing it here. We'll see exactly how to do this within React. But here, we just need to add an object. All of the variables are organized in an object. Since our variable is named ID, we can just write ID, and it's going to suggest it to us. So the ID variable needs to be set to some value, and we mentioned that was either going to be 0 or 1. And upon second thought, let's say we want to get rid of sleep. So let's set ID to 1 here. Now let's try this. Hit play. And then to check to see that our to-do was deleted with the ID of 1, we can re-execute fetch to-dos. And we see that it's gone. Perfect. So what we've been using so far, this to-dos GraphQL API, has been really useful in terms of understanding all the core components of GraphQL. But obviously we want to be able to make our own GraphQL API that can manage our own database, which keeps track of our own app data. So how do we do that? How do we create our own GraphQL API? We're going to be using a very powerful service called Hasura to do so for us. So we're going to open up a new tab and go to hasura.io. And what's so great about Hasura is that we can get started with our own custom GraphQL API really in a matter of seconds. All we have to do is click on this link to try it out in 30 seconds on Heroku. And once we're at this quick start page, we can scroll down and click on the Deploy to Heroku button. So if you don't have a Heroku account, you'll want to create one right here. It's entirely free to do so. Creating our APIs will be entirely free as well. And by deploying our API with Heroku, it's going to give us a very convenient URL to go to and start working with our API. I already have an account with Heroku, so I'm just going to log in. And once you've signed up or logged in, you're going to be prompted to include your own app name, what you want to call your API. I'm going to call mine React to do GraphQL. And then we just need to scroll down and hit Deploy App. And that's it. It's going to go through the whole process of creating our app, configuring the environment, and you'll see the entire deployment log right here. And once you see that it's been successfully deployed, you'll just want to click on View right here, the View button, and you'll be taken to the Hasura console. So at this point, we've bootstrapped a brand new API. When we go to our console, we'll immediately have access to our Graphql Explorer. You can see it right here. But at this point, since we're working with a brand new API, we're going to be the ones that configure the schema. And you can see how we need to do that right here. We're going to be prompted to click on the Data tab to create some tables. So let's take a step back and discuss what Hasura is actually going to do for us. Let's talk about the architecture of Hasura. What's excellent about Hasura is how little configuration it needs to do everything that's required in our backend. So in addition to giving us a GraphQL API, it's also given us a database. And the way that everything's going to work is that we just need to tell Hasura, hey, our database is going to consist of this data. Every data type is going to exist in a separate table. And when we do so, when we tell Hasura what data we're working with, it's going to automatically generate our GraphQL schema. It's going to generate all the queries and mutations that we need, and that allows us to use those queries and mutations directly in our client. So the process is going to work like this. We describe our data to our database in tables. A GraphQL schema is generated for us with means of interacting with our database, and we can use that directly from our React client. This will all make sense in just a bit, but let's get started building out our tables, describing the data that we're going to be using. So let's head back to our API Explorer, and instead of being in the Graphical tab, let's go over to the Data tab. So to auto-generate our schema, we just need to hit the Create Table button for our first set of data. We want to give this a name. Since this is virtually always going to be a set of data, we want to make sure that this is plural. So since we're going to be recreating our to-dos API and make a little app or make a little React application based around it, let's call this table name to-dos, plural. So if the table is the type of data that we have in general, the object type, our columns are the individual fields, the subfields. So for each to-do, we had an ID. So that's what we'll call this column. Then for the column type, we want to make this a unique ID. So we'll select the column type UUID here. And then in this last input, for our first column, we can specify a way to generate this ID. So we'll just select it and choose the option gen random UUID. This is just a function that allows us to generate a random ID. You'll also see the options here, the checkboxes here for nullable or unique. If we wanted to make a given column nullable, if we wanted to say it's okay that there's no ID, or if we want to ensure that it's unique, we would check either one of these boxes. However, we don't need to for the unique checkbox because this is going to be unique by default. And for the next column, we had text. And for its type, this is going to be of type text. There's going to be no default value, and it's not going to be nullable or unique. And then the final column will be done for the done field, and that was a Boolean, so we'll select that, and the default value for it was false. So now we've described our new data type with columns, and we just need to select a primary key. If we look at the tooltip here, we'll see that a primary key is a column or set of columns that uniquely identify a row of a table. And it would make the most sense here to have our ID column represent that, since it's a unique identifier. So we'll select ID for the primary key. And you can read more about foreign keys and unique keys, but we don't really need them here. And as you can see, these aren't required at the moment. You can add them later. And now that we've described this new type of data, we can select Add Table. So now our table's been created. We're still in our Data tab, and our one table is listed here on the left, To-Dos. And now we can see a summary of all of our columns, as well as the options that we chose, and we can edit them later on if we need. We could also add new columns, new pieces of data to each to-do if we needed to later on. So now let's check back with Graphql and see what we have. And previously, we didn't have any schema here, but now if we look at the Documentation Explorer, we see that we have 3 sets of operations: queries, mutations, and subscriptions for all of our to-do data. So we haven't covered what subscriptions are just yet, but we will in a matter of minutes. So we can dig into any one of these and see the different queries or mutations that have been created for us. So this is something that Hasura has generated for us automatically based off of our data, and we can start working with them right away. So let's close our Documentation Explorer, and there's an Explorer here on the left that's even more convenient, where we can just select different options that we want instead of having to write in our queries ourselves. Of course, we still can manually, but we don't need to. So right here for our different options within query, we have to-dos, to-dos aggregate, and to-dos by PK, which means primary key. So let's ignore these last 2 queries for now. We can use this to-dos query to fetch data from the table to-dos. So Hasura has named this query a little bit differently than what we had in our previous API, but if we just select this, we see immediately our query is created. It has the default name myQuery, but we could give it our own name, say get to-dos. And for this query, we have a number of arguments up here that we're not going to cover just yet. Underneath, we see all of our familiar fields that we can get back from each to-do, each subfield: done, ID, and text. So immediately once we check them, they're added to the query that's been written out. And just like before, we can execute this. We get back a familiar structure, but note that to-dos as an array is empty because of course we haven't added any data. So let's add a new mutation. Note that in GraphQL you can execute multiple operations at the same time. That is to say, you can batch multiple operations within the same request, but for now let's just do one at a time. So let's write out our first mutation. This will be to add a to-do. Then to write this out, we need to figure out the appropriate mutation. So we have delete to-dos, insert to-dos, and update to-dos. Inserting to-dos is what we want. We want to insert data into the table to-dos. So we'll select that. Our arguments are provided a little bit differently than before. It's provided on this objects argument. Instead of having to list them out as multiple arguments, we can provide them within a single argument. And if we hover over to-dos, insert to-dos, we're going to be told that we need to provide a selection of subfields. We can figure out what this requires if we go into our documentation. We go into the mutation root type. On insert to-dos, see that the objects argument accepts an array of this type to-dos, insert input. And we can technically provide all of these if we wanted to. But since done has a default value of false and the ID is going to be automatically generated, we just need to provide some text as before. So we'll set text to take out the trash. And we'll provide our subfields. For mutations, that's going to be on returning, on this returning subfield. And that's where we can get back the values that we want from the newly created to-do. So let's hit play. And we get back in this returning array our first to-do as an object with done set to false, a unique ID, and the text that we specified, take out the trash. So now if we go back to history and select our original query get to-dos, we can now execute that. And we see our to-dos array now just consists of one to-do. And perhaps an easier way to directly change this data, say if we wanted to change done to true here within our application, we could of course use the appropriate mutation, where if we were to look at it, we could see that would be update to-dos. We could certainly do that, but if you want a more direct way to change data, you can just go to the Data tab, go to the tables, go to the appropriate table, and you can see listed here at the bottom every individual piece of data that you have for that table. And then you can appropriately edit this row. So the types of data are referred to as tables, and the individual entries are referred to as rows. We use this terminology because behind the scenes, Hasura uses a SQL database to manage all of our data. We can edit our data with the edit button and delete our data with the delete button. And the last thing I want to cover before we end this section is subscriptions. We've covered queries, mutations. What's a subscription? So of course with queries we get data. With mutations we can change data. But with subscriptions we can subscribe to changes that take place with mutations in real time. So subscriptions are very similar to queries, but queries are not real time. They don't pick up new changes as they happen. We have to re-execute a query in order to fetch the latest data if a mutation has taken place after executing the query. So let's see how to write a subscription. If we just select Add New Subscription, we see we have very similar options to adding a new query. And once again, we'll just select To-Dos, where we can grab all of the fields of our to-dos. And let's execute this like a query. So first it runs like a query, but instead of showing the play button once again to re-execute it, it continues to subscribe for any updates. And it does so by using WebSockets, what's known as WebSockets, as compared to a simple HTTP connection. So if I just open up my Explorer in another tab, and let's say I create a new to-do. So we'll select Add To-Do, and we'll give it the text, Pay Bills. What's going to happen when I add this to-do? Well, when I add it, when that's created, if we flip back to our running subscription, we see immediately in our to-dos array, Pay Bills is added to the end. And any change in our to-dos table is going to be picked up immediately. So alternatively, if we were to update that new to-do, if we were to set done to true, so we'll write that mutation, we'll select Update To-Dos, and this is a little bit different. To update a to-do, we need to provide this where argument. We want to update a to-do where the ID, we can find it by its unique identifier, its ID, where the ID, if we select that, is equal to, you see this list of operators that we can use. We want to find a to-do where the ID is equal to underscore EQ, and some of these other operators mean greater than or equal to, is in, say if we have an array, is null, is less than or equal to, is not equal to, or is not in. We have all those options, but we just want the simplest one, is equal to the given ID. And we want to set, using the set argument, we'll select that. We want to select done to true. Very easy. We don't have to write that out ourselves. And now if we scroll down, we can collapse the where and set arguments. We don't need them. We can look at returning, and then we can provide whatever fields that we want. Oops, I shouldn't have done that. We want to leave them open to actually execute our query, but once we update a to-do, when we hit play, done is set to true for our pay bills to do. If we flip back, it's picked up immediately by our subscription. This is why we're going to be using Hasura as our serverless backend. We can create it quickly, it gives us a GraphQL API right out of the box, and we can configure it just by telling it, by describing to it what data we're going to be using, and then it gives us all of the means of interacting with our database. And we're going to see how to use all of these queries, mutations, and subscriptions through making several apps, the first of which will be a to-do app, where we can let users keep track of their to-dos directly through the React app that we're going to be making. And in the next step, we're going to look at the tool that's going to allow us to use GraphQL and use all of these operations from Hasura directly within our front-end React app.